Thanks everybody for joining this session of the status of ProxySQL and the 2020 edition. Basically, we're going to discuss about what is new in ProxySQL this year. So, quick note about myself. My name is Rene Cannao. I am the founder of ProxySQL LLC and the author of the same software, the software with the same name. So, my background has been mostly as a MySQL DBA. So, we as a company we also provide services around ProxySQL. So if you're interested about ProxySQL support service, DBA consultancy, development and training, just please feel free to reach out. Also, we are hiring. So quick note here, if you are an experienced coder in C++ and you're interested in MySQL development and everything around MySQL, please feel free to reach out. And of course, we are completely working remotely. Here, a quick overview of the company using ProxySQL. Of course, this list is not complete, just a few names here. So, our agenda. We're going to discuss all the features introduced in 2018 related to ProxySQL 2.0 and also what is new in ProxySQL 2.1 that is going to be released very soon. So, about 2.0, what the feature introduced in 2020. We're going to discuss about the REST API. We're going to discuss about the firewall, all the new SSL features, improved scalability, a lot of new settings that have been introduced in this major release, and also the support for ARM processor. Instead, what is new in ProxySQL 2.1? We're going to discuss briefly about performance enhancement. We're going to discuss about all the new cluster capability, extended attributes, the SQLite plugin, very interesting features, other minor features that have been introduced in the same version, and the Prometheus exporter and enterprise web UI. Those are a very big deal related to ProxySQL 2.1. Now, let's start with the REST API first and foremost. So, what is the REST API in ProxySQL? So, we introduced this ability of creating endpoint that a client can reach through an HTTP request. And on this HTTP request, basically the client will connect to a specific URI. It can eventually pass some certain argument, and ProxySQL will execute a script that will process those arguments. The script will perform some action and then eventually can return a result to the client. Now, what are those scripts? Well, the scripts, of course, are something that the users create and that configure ProxySQL to execute. So there is no built-in script in ProxySQL or built-in functionality that are being executed when hitting those endpoints, but instead the end user can create a script and load them into ProxySQL, and ProxySQL will be able to execute them. Here is an example just to show how it looks like. Now, how to enable it? Of course, you enable through global variables. The global variables is called admin REST API enabled. By default is false, so you have to explicitly set to true. And the default port is port 6070. Of course, also this can be configured. Now, how does it exactly work? So, as if you're familiar with ProxySQL, you know that almost everything is configured in a table. So there is this table called REST API routes, in which the users can configure if that specific endpoint is enabled or disabled. Then it can also specify a timeout. So, for instance, you can specify that a certain script should not be run for longer than a certain period of time. And if it goes beyond a certain period of time, ProxySQL will automatically terminate it. Also, you have to specify the HTTP method. It could be either get or post. Then the URI. The script is basically the executable that ProxySQL is going to call and pass the argument if the client, HTTP client, has passed any argument. And then an optional comment that could be anything. Now, here is an example of how to actually configure it. So you basically have to insert a row into the REST API routes. This is the classic way of configuring features in ProxySQL. And in this table, you configure that is active. You configure a timeout of 1000 milliseconds. The method in this case is a post method. The script that is going to be executed is an export users. Sorry, this is the URI export users, and then the script is a script in the script directory called export user.py, and then a random command. Now, HTTP client can pass argument in any form because those arguments will be passed to the script. So whatever format the script is able to interpret, ProxySQL will just pass those arguments to the script. We personally recommend to use JSON format because it's richer as a way of providing multiple arguments. So in this example, we are calling this script and the export user script, specifying a series of arguments, and those arguments are a DB object and an admin object. So the admin object is nothing more than instructing this script on how to configure, how to connect to ProxySQL itself, and the DB object is the coordinate of another database server. So what the script does in this specific example, it will connect to the database specified in the DB object, and it will retrieve the users from this database, and it will configure ProxySQL using those users. So it will have to connect to ProxySQL. Now, if the script return any result set, those results are passed to the client. Again, we do not enforce any format for a result from those scripts, but again, we recommend it to be JSON, so the client normally is able to interpret it in a nice way. Now, the firewall whitelist. ProxySQL has had always a way of blocking queries using the error message in the MySQL query rules tables. So in the MySQL query rules tables, there is a column called error message. If it is enabled, basically the query will be rejected. So let's just have a quick diagram to show this. The query is coming. Does it hit our query rules with error message? If it's yes, the query is blocked. If it's not, the query is executed. But so ProxySQL, MySQL query rules error message provide a way of blocking queries, but it's basically the way you configure it normally is that you specify all the criteria for blocking queries. Of course, this becomes a bit complicated if you have a lot of rules, a lot of query. You can also convert it into an allow list. So you can specify a lot of queries that are allowed to be executed, and at the end of this list, you just have a catch-all rules that says, well, block everything else. And of course, again, this is quite complicated if you have a lot of rules. So we decided to implement this a lot better using whitelist tables. Specifically, we implemented two tables, one called MySQL firewall whitelist users and another called MySQL firewall whitelist users. So again, those are configured using tables. You have username, client, and then in the MySQL whitelist users, you have a mode. And this mode could be either off, detecting, or protecting. If the mode is off, basically what happens is that all the queries are allowed. If the users is configured in detecting mode, basically all the queries are allowed, but if they do not match whitelisted queries, they're basically logged in the error log. And then you have the protecting mode. So in this mode, only the queries that are explicitly whitelisted are being executed. So where does it happen? Where the queries that are allowed are listed? They are listed in a table called MySQL Firewall Whitelist Rules. So let's have a quick look on how things works in practice. So during a normal traffic, what happens is that query hitting the query processor, the processor will perform some action, and then it will execute the query. And after it executes the query, it also logs all those statistics about the query, including the digest, in a table called stat MySQL query rules. Now, what it can also perform once we have the firewall implemented, the query processor will query the whitelist user table to know if the users if the user executing those query, what to do with the query executed by those users. Either allow them, so they are being executed on the backend, or they're just rejected, so the client will receive an error. And so far we spoke about this implementation. So why the stat MySQL query tables is important? Because, well, it collects a lot of statistics related to the query. So it collects the host group, the schema name, the username, the client address, and also the digest of the query. So the digest text and so on, when it was executed, etc. So those information are very useful, and those information can become even more useful in configuring the other tables related to firewall. That is the MySQL firewall whitelist rules. So basically, this table, what it has multiple columns, but what are interesting are the username, client address, and the fact it has digest. The digest has to be the same of the digest available in SAP MySQL query digest table. So basically, how to combine all this together. So going back to the diagram, when a query is hitting the query processor will determine the mode of the users. It could be either off, detecting, or protecting. If it is detecting or protecting, then it will query the whitelist rules table to determine if the query is allowed or not. And how we configure these tables? Well, we can configure this table getting data from stat MySQL query digest. So this is actually something very interesting, the way we construct it. The way basically that we populate this table is that we let ProxySQL run for some time. It will collect statistics. It will basically learn about the traffic that is passing through ProxySQL. And then later on, we can use what ProxySQL has learned to create rules to allow only the queries that are known and to block everything else. Now, there is a minor limitation here, is that the stat MySQL query digest is a table that is just in runtime. So if you want ProxySQL to run for a very extended period of time, probably you will have some mechanism that is at regular interval cleaning this table. So we introduced features that allow to store the information from stat MySQL query digest into a persistent table on disk called history MySQL query digest. And this table structure is absolutely identical to stat MySQL query digest, with the only exception that it also has a dump time. This dump time is the time when the data was moved from stat MySQL query digest to history MySQL query digest. Now, how to perform this operation? You can have it either manually or automatic. So you can do it manually or with a script, of course, just executing the command save MySQL query digest to disk, and ProxySQL will copy the data from stat MySQL query digest to disk. Or you can do it automatically, setting a value to this table called admin stat MySQL query digest to disk. This represents the number of seconds, and every X number of seconds, ProxySQL will automatically move the data from stat MySQL query digest to history MySQL query digest. And going back to the previous diagram, this is how it will look like. So the statistics about the query are copied from stat MySQL query digest to history MySQL query digest. And you can use either of those two tables to configure the MySQL firewall whitelist rules. So very simple. How to actually configure them, like what are the query required. Here there are some examples. So if you want to configure the whitelist users, it's very simple. You have to execute an insert statement, selecting the user from the MySQL user table, and then also specifying which mode you want, like detecting, off, or protecting. And similarly, to configure the MySQL, the firewall rules, you can just query from stat history, stat MySQL query digest, or from stats, stat MySQL query digest. So you basically have to copy the username, the client address, and the digest, the schema name and digest. Also, we introduce some commands that are specific for the firewall. And this has very similar pattern of other module in ProxySQL. So in ProxySQL, so you have this command called load MySQL firewall to runtime, save MySQL firewall to disk, load MySQL firewall from disk, and save MySQL firewall from runtime. Also, very important, you need to remember to configure the firewall globally, because all those tables won't take effect unless the firewall is globally enabled. So the configuration will be null if the firewall global is not enabled. So very important to remember this. Now, other important features introduced in 2.1. Well, specifically in 2.1.11, we introduced two new interesting features. One is that idle thread is enabled by default, and then MySQL query rules fast routing. We improve the way it works. Specifically, we allow to look up without username. So what is the idle thread that is enabled by default? ProxySQL normally has a certain number of worker thread, and those worker thread, they handle all the connection. But there are a lot of applications that create connection, and then those connections are not used for a certain period of time, and could range from few seconds to just a few milliseconds. And those idle connections, they create some load, and because ProxySQL has to process them even if they are idle. So with the implementation of these features, ProxySQL is able to pass those idle connections to an auxiliary thread, and those auxiliary threads are the one responsible for handling those idle connections, while the main worker threads are the one that are handling the traffic of the most active connection. This allows ProxySQL to scale to hundreds of thousands of connections without having any CPU performance, any performance hit on CPU. Now, the other interesting features we introduce is an enhancement on the MySQL query rules fast routing. Quick introduction on what it is. ProxySQL allow sharding, performing routing based on username, schema name, and flagging. And of course, if you have only a few shards, that's fine. ProxySQL handles it very well. But if you have 100, still everything is okay. But if you have thousands or tens of thousands of rules, then performance starts degrading quite quickly. So long time ago, we implemented a new tables called MySQL query rules fast routing, in which we do not have this performance penalty. So it under the hood is implemented as a hash table. So no matter if you have 10 rules or 200,000 rules, the performance is almost identical. The bottleneck here, the drawback here is that it actually will consume a lot of memory because it has to create those huge mobs. Now, in 2011, we introduced the ability of having rules without the username. So if you have a lot of users that they all use the same schema, you can just create one single rules that apply to all users instead of having one rules per schema. This improves memory utilization, but also simplify the configuration, because if you have 100 or even 1,000 of users, you don't need to create a rules for each of them, but you just create one that applies to them all. So that was an enhancement. Then about SSL, we perform some upgrade of OpenSSL, and also we implement the loading of intermediary certificate chain. This allows client to connect to ProxySQL using the verify CI flags. Also, in ProxySQL 2013, we finally implemented SavePoint. So transactions were always supported in ProxySQL, but SavePoint were not implemented yet until version 2013. Furthermore, we also introduced a new annotation in queries. So if a client executes a query with the annotation that is create new connection equal 1, ProxySQL will force the creation of a new connection to execute that specific query. In 2014, we also had the ability to compile ProxySQL on FreeBSD and also macOS. And also we implemented a few more variables, specifically the MySQL connect timeout client. So if a client connects to ProxySQL, but is idle for a certain period of time, ProxySQL will automatically disconnect the client. Previously, this wasn't happening. So if there was a failed authentication to ProxySQL and the client were not completing it, ProxySQL was waiting forever. Also, we implemented new variables called MySQL monitor replication lag count. And this solves the problem of having replication lag that is spiking. So it might happen that the replication lags spikes for a short period of time, sometime even less than a second. And ProxySQL was performing the check during that specific moment and was detecting a large replication lag, so it was disabling the server. But then 1 second after, replication was again back to normal. These new variables allow ProxySQL to perform multiple checks before disabling a server that is lagging. Furthermore, we also added support for Ubuntu 20, and now all the new version of ProxySQL for recent Linux release also have ClickHouse support enabled by default. So we don't have any more two different packages. In 2015, we introduced extra variables called MySQL max transaction idle time. This solves a very interesting problem. Before, we had function variables called MySQL max transaction time that was incorrectly named. Basically, this was previously killing all the transactions that were idle beyond a certain threshold, while in reality the name suggests that this was the total time. So we basically fixed this naming unclarity, and we also introduced a new variable called MySQL transaction idle time that performs what the original variables was doing. Also, on the same version, we had ProxySQL building and running on ARM processor. And furthermore, we are also providing official packages for CentOS since version 7, and for Debian since version 8, so 8 and 10, and since Ubuntu 18, so 18 and 20. Furthermore, we also have Docker images available. So if you're running, if you want to run ProxySQL on ARM, you can either use our repository or a Docker image. We have those available. Now, new features in ProxySQL 2.1. That's the most interesting on the list. So we upgraded a lot of core dependencies. So ProxySQL relies on third-party libraries, and we upgraded most of them. So specifically, the MySQL Connector C has been upgraded to 3.1.9. We upgraded several of the regular expression library, OpenSSL to the latest, and the SQLite to 3.19.12. Also, we performed a lot of refactoring, and that's allowed us to have simpler code in a lot of portion of ProxySQL modules, and also we found some way of improving performance in certain specific code path. Now, we also performed several improvements on ProxySQL cluster, but before explaining those improvements, let's just open a small parenthesis and describing what is ProxySQL cluster. So ProxySQL cluster is its own native configuration management. So basically, multiple ProxySQL nodes are able to monitor each other and synchronize their configuration if the configuration in one of those nodes has changed. So basically, it implements some sort of replication. Change the configuration in one of the nodes, and it will replicate everywhere. Historically, we have the monitoring and synchronization of MySQL users, MySQL servers, MySQL replication host group, MySQL query rules, and ProxySQL node themselves. So which are the nodes that are part of the cluster. Now, in 2.1, we performed several enhancements. Specifically, first of all, we did the upgrade of the way that the proxy communicate between them. And now in ProxySQL 2.1, all the communication uses SSL. This means that all traffic between the proxies is encrypted. So this also means that if there are credentials that are being exchanged between those proxies, they are encrypted on the wire. Also, when they connect to each other, they also verify each other version. So, and this is part of the handshake. So when they connect to each other, and if they detect that the other proxy has a version that is different from their own, so if the version does not match, they won't be part of the cluster. So they will ignore each other. This solves the issue of having conflicting configuration or conflicting table structure between multiple ProxySQL versions. So if the version does not match, they are not able to monitor each other, and they're not able to replicate the configuration. Also because the configuration will be incompatible between two proxy of different version. The fact that they check the version allow us to finally synchronize also the variables. So the admin and the MySQL variables are now replicated. This before was not possible because it was very possible that two minor releases of ProxySQL had different variables. So if the variables were different, they were never able to synchronize. So now with this, now we are able to synchronize also those variables. Furthermore, we are now synchronizing also the tables that are related to MySQL cluster solution. So specifically, the tables related to Aurora, the table related to Galera, and the table related to group replication. Great. Now, what else? We also had, we introduced the extending attribute. So let me explain what that means. So every time we want to add a new columns to a table in ProxySQL, this normally means creating a new feature. So for every feature, we create a new column. This creates some interesting problem because it doesn't allow us to create new column within a minor release upgrade, because otherwise the table structure will change. Then you have external tool that will stop working, and there is increased complexity in the ProxySQL cluster itself, because now extra columns need to be supported. So the configuration management in ProxySQL cluster itself becomes more complicated. So we add the ability of adding one extra columns called attribute, and we configure this in two tables right now: the MySQL user table and the MySQL query rules table. I will show an example now. So this is the MySQL user table. What we are doing is just adding this column called attribute. This column called attribute. This column is a varchar, by default is an empty string, and it is either a JSON or an empty string. And SQLite itself will perform the input validation, so it will make sure that whatever we are writing there is a valid JSON. So as I said before, either an empty string or a JSON, and every new feature that we want to introduce, either on the MySQL user table or on the MySQL query rules, we can just add these new features as a new object in these JSON attributes. Now, the SQLite plugin. ProxySQL has been using SQLite as its own internal database since ever. It uses SQLite for both in-memory database, so basically the admin when you connect and you configure ProxySQL, but also to persist the configuration on disk, and also for statistic purposes, everything is stored into an SQLite database. And the way we do this is because we have SQLite embedded into ProxySQL. Now in 2.1, we have the ability of replacing the embedded SQLite database with a plugin. And this plugin will provide external capability. For example, this plugin, the SQLite plugin, will also support the SQLite encryption extension. And this becomes very interesting because this means that the very first features that will be implemented is the ability of having the database encrypted at rest. So the database file that is on disk, it will be encrypted. So all the credentials are stored there, and they will be basically encrypted, not just protected at the system level, but also encrypted. Now, we also introduced some minor optimization in the way that MySQL query digest process query. Specifically, we found different bugs in the way numbers are being handled. So we improve this, or how we handle space. So this is handled in 2.1. Another important features with regard to MySQL query digest and the way ProxySQL generate digest is how we handle a long list of parameters. So it's quite common to have application that issue queries with a variable number of parameters, like 4, 5, 6 parameters, and so on. And ProxySQL generate a distinct digest for every number of parameters that are available. And somehow this makes sense because you might want to have a different digest if a query has only one parameter or only two parameters or three. But once you have 10 parameters or 50 or 100, it doesn't make any difference, because it just means a long list of parameters. So we introduced these new variables called MySQL query digest grouping limit. And if the list of parameters goes beyond this threshold, that by default is 3, ProxySQL will just list a certain number of parameters and then will just replace with a series of dots. So all the queries with a number of parameters beyond this threshold will all generate the same digest. Also, we have multiple ProxySQL commands in the admin. We have the ProxySQL stop, start, and pause, that those are related to the MySQL module. So it's able to stop, start, and pause the MySQL module itself. And in 2.0, we had ProxySQL kill and ProxySQL shutdown. ProxySQL shutdown, what it does is a graceful shutdown of ProxySQL. So it will disable all the module and basically shut down. We realized that the ProxySQL shutdown is not really useful in production environment, but mostly for development. So we decided that ProxySQL shutdown now is being mapped to ProxySQL kill. So ProxySQL just exit as soon as possible. And we added a new command called ProxySQL shutdown slow that will be mostly used for development purpose when we want to perform a graceful shutdown of ProxySQL. Now, the Prometheus exporter. This is probably the most interesting features that we are going to speak right now. So, in a classic setup, what you have is that you have an application that generates metrics and statistics, and then you have a Prometheus exporter that connects somehow to this application in a variety of way and process metrics from this application and transform those metrics in statistic. And then you have a Prometheus server that basically scrape the exporter to get those metrics and gather them into internal time series. Now, ProxySQL, we decide, this applies also to ProxySQL at version 2.0, but in ProxySQL 2.1, we decide to implement these features even better, and we decide to embed the exporter inside ProxySQL. So now ProxySQL in real time is able to generate those metrics and have them in a format that are ready to be scraped by the Prometheus exporter. So the Prometheus exporter, all it has to do is to connect to ProxySQL and scrape those metrics. So getting a bit more into details, as I was saying, this becomes easier to configure because you don't need an external tool anymore, and ProxySQL generate those metrics in real time. So all you have to do in reality is just to configure the Prometheus server to connect to ProxySQL and scrape at certain interval. This is an example of how it looks like. So ProxySQL itself, listening on port 6070, will export those metrics. Also, we are building Grafana dashboard. So, of course, once you have all those metrics that are copied from ProxySQL into Prometheus and stored in a time series, now you will be able to visualize them in a Grafana dashboard. We are making those dashboards publicly available, and those dashboards will allow users to see the status of ProxySQL, if it is healthy, the status of the backend, how many queries are being executed. So to have a generic information about the health of the proxy, but also to get into a lot of details. Here there are a few examples of those metrics that are being instrumented. Now, the final interesting features that has been introduced in ProxySQL 2.1 is the enterprise web UI. So what is exactly the enterprise web UI? So it is nothing. It is basically a graphical user interface that allows to configure ProxySQL through a browser. So it is a web UI. And from here, you will be able to configure ProxySQL, but also to check the status of it and also view all the monitor information. So as you know, ProxySQL has its own monitoring module, so it check the health of the backend, and all those information are available through the enterprise web UI. An important thing to remember is that the enterprise web UI is currently implemented as a plugin available only to enterprise subscribers. So what we have in it? Well, we have a very simple dashboard. The reason why this dashboard is simple is because we don't want to duplicate all the work that we did for the Prometheus exporter and Grafana. So the dashboard here is very simple and shows very few information. But the interesting part is in the configuration of ProxySQL itself. So here, for example, we can see all the users that are currently configured in this ProxySQL instance. And those users, you can delete them, or if you click in one of them, you will be able to update it, so edit this configuration. And also you are able to see the data from either the main schema or the runtime, so which users are actually being used by ProxySQL, or what is on disk. So you're able also to see the configuration that is saved on disk. Also from this dashboard, you will be able to load the users to runtime, save them to disk, and so on. So all the operation that you normally do through the admin interface, now you can do them through this web UI. And this applies to the MySQL users, and just an example, this applies also to the MySQL servers. Again, just click in one of them and you will be able to modify it. Now, further this, of course, you can also create users and create server users shortly after. So it's very simple. Here you have to configure the username, the password, which is the default schemas, and all the settings related to the MySQL user, and then just save it. Similar thing for the MySQL users. So again, you specify the host name, the port, in which host group the server will apply, maximum number of connection, and so on. And of course, this applies also to all the other configuration tables, like in this case, the MySQL replication host group, Galera, group replication, and AWS Aurora. So all the servers, all the cluster configuration, they are all configurable through the web UI. Also, you have very similar things with regards to the MySQL query rules. So again, here from this list, you can delete rules, you can modify them. And if you're familiar with the MySQL query rules, you know that normally you have really a lot of settings here. So we also have, to make it more readable, we added the ability of choosing which columns you want to visualize. And this becomes very handy also when you want to create new query rules, because here, for example, when you create a new MySQL query rules, by default, you have the most common columns. But if you want to have other option available, you just have to click on the name of the columns and it will be available for editing. So again, once you create them, you can save the rules from here. And again, you can load them to runtime, save to disk, and so on. Also, from the same web UI, you're able to configure the admin and the MySQL variables. So they are here. Again, from here, you can see what is loaded in the main configuration, what is saved on disk, and what is loading at runtime. And from the same interface, you can load the configuration from main to runtime, or from main, save them to disk. And as well, allow you to configure the firewall. So the MySQL firewall, there are pages that allow you to do this. So both the users and the rules, everything is here. And also from this web UI, you're able to verify also the status of ProxySQL in all its stats tables. In this example, we are only showing the connection pool. So from here, you can see which servers are online, which one are serving traffic, how many connections are being used, how many connections are being created, and so on. Every tables in the stats schema is available for visualizing in the enterprise web UI. Similar things is for all the monitor table. So they are all visualizable here. And in this example, I'm only showing the MySQL connection pool. And my session is finished. Thanks for joining. And if you have any questions, please feel free to ask on Slack, and I will try to reply. Thank you.
Thank you, Rene, for joining and speaking for MinervaDB Athena 2020. Welcome to the event.
Thank you, Shiv, for having me here.
Thank you. It's always a great pleasure talking to you every time, Rene. I tell you why. The conversations with you will have a lot of technical insight. You are the product owner, but often you lead the product technology talks towards the compelling needs of database infrastructure owner or a DBA. That is a creation of Proxy SQL. So let me personally thank you from our committee for submitting this talk about Proxy SQL new features. I tell you, the topics which I want to discuss with you in this virtual fireside chat is like, how do you see like the adoption strategy of Proxy SQL? How early is Proxy SQL beneficial for adoption? Is it like, as we all know that every internet property starts with a single database server until they realize they can't have a single point of failure, then they have a second database server, then goes third, then the number goes high. So do you have one point you say like, hey, this is the right point for you to think about load balancing? So how do you recommend? You've been a DBA, you are a DBA, you've been a DBA, so yeah.
So it really depends on when you feel the need of being able to intercept the traffic that is being sent from the application database and be able to perform any sort of transformation. Because if you want to have your transformation that is related to caching and query write, you can start using Proxy SQL from really day one, even if you have just one database server as a backend. Of course, it's never recommended to have just one database server, but it's quite common to have only one database. So if your goal is to be able to introduce features like caching and query write, you can start absolutely from day one. If those are not your top requirement, so the feature that you really need, and instead you want to use Proxy SQL for load balancing the traffic, so to distribute the traffic to multiple readers, or later on if you want to split the traffic between readers and writer, then of course you can implement Proxy SQL later on when you feel the need for those features. But again, those are not the features that most users use. There are some features that other users are more interested on, like for example the ability of multiplexing. And again, most of the users do not think about these features until they hit the problem of MySQL not being able to scale beyond a certain number of connections. And so at this point is when they start looking into Proxy SQL. We have quite common cases in which MySQL is being hit by tens of thousands of connections and then performance start dropping. So there is the perfect time to start investigating using Proxy SQL in this deployment because it can drastically reduce the number of connections. Now, back to your question, when is the best moment to start using Proxy SQL? Is it the beginning or when your infrastructure is way more complicated, more complex? In reality, this is up to you because Proxy SQL has no increased difficulties in being deployed at an early stages or a later stage. So it really depends when you need the features that it provides.
Yeah, wonderful. Like I tell you, technically the biggest challenge is about choosing the operational the database infrastructure operational tools. I call them as a generic operations tools. The reason because it's like when I'm looking forward to scale my database systems like MySQL, definitely I look forward to sharding the MySQL ecosystem in my database infrastructure. Here the challenge is like most often, right? Scaling reads is quite a direct method. Many of our customers, right? I don't know whether you experience that. I mean, like when I talk to many of the customers, hey, can we scale writes? So we strongly discourage scaling writes for several technical reasons. But now when I have a load balancer, right, as Proxy SQL, which is intuitive to route the read, right, uh, then if I have an underlying hardware infrastructure, which is capable of providing ultra low latency packet communications, do you recommend multi database infrastructure writes with new Proxy SQL, or or you say no, or you say like be cautious?
Well, it really depends from the database clustering solution that is behind ProxySQL. Like, if, for instance, if behind ProxySQL you have some cluster solution that allow multi-write, like Galera or MySQL cluster or group replication, and the writes are successful to be redirected to multiple writer server, yes, absolutely, that's a good idea. And also, furthermore, we also have this ability of routing traffic based on some specific pattern. So it's also possible that to avoid conflict, you can configure ProxySQL to route the traffic to a specific schema to one server, while all the traffic of for a different schema on a different server, or you can go even more granular, like all the traffic to a specific set of table to one server, while all the write to another specific set of table goes to yet another server. So it absolutely allows also
Understood.
to shard the
Understood.
writes.
Understood. Understood. Now, what you see is, for me personally, what really appeared great as a Proxy SQL end user, Proxy SQL, um, like you recommend. I mean, I recommend Proxy SQL for many of our customers when they are, as you rightly said, when they are up to a point that, hey, something we need to seriously worry about scaling the read and writes with a load balancer, and don't want application to decide about read write splitting. Now, technically, what I really get excited to work on Proxy SQL. One is like query cache. We all know that MySQL implementation of query cache was not suited for most of the scenarios. It was suitable for some set of scenarios. Great. If you're a CDN, it works great. But then if you have a very dynamic queries, and if you're looking at the most of the consumer facing internal properties came out of using MySQL query cache, and thankfully Proxy SQL introduced it. So I'm a big adopter of that. Two is about data privacy, right? If I'm looking at building a firewall on top of MySQL today, it's less intensive if I have Proxy SQL, right? What do you think as a product owner? You get really excited with a new feature, maybe like one, two new features. If you see like, hey, something, adopt it, learn about it, it really makes an impact.
Yes. So we have this ability of creating new features on almost any new release. So we
Mm-hmm.
started originally as query cache and query rewrite. Query rewrite is also a very good way of rewriting query also in terms of privacy. So certain query are never able to get some specific data if they are being queried, or to obfuscate the data using a rewrite. But then later on, we also introduce the ability of blocking queries. And this ability of blocking queries, it evolved over time, and now is a full-fledged feature that is the Proxy SQL ability of act as a firewall. So we have these features that basically Proxy SQL can learn all the traffic that is passing through it and querying the database server, and builds its own database of queries that are allowed to be executed. And after the administrator of ProxySQL can basically turn ProxySQL into a firewall and allow only the queries that ProxySQL has learned in this process. So every new query that ProxySQL never saw before, it will be automatically rejected. This is absolutely one of the best features that I like that this actually a recent features that is available since the beginning of this year. It's a very powerful one in terms of security. Then other interesting features that I am very excited about are the Prometheus exporter. As I was saying before, we always introduce new features, and now we have also this ability of exporting metrics. We always did export metrics, but before those metrics needed to be extracted from the ProxySQL statistic database and by Prometheus exporter, and then this Prometheus exporter were normally sending data to Prometheus server, so the Prometheus server was getting them. Now instead, we have the ability of instrumenting those metrics, so the Prometheus server can actually automatically get those metrics directly from ProxySQL. Of course, for this to happen, we also have web server that is built in inside the ProxySQL. So this is extremely useful. And related to this, we are also developing and will make available very soon also some Prometheus, some Grafana dashboard, so people will be able to have to monitor the status of ProxySQL using our recommended dashboards. And speaking about web server, another interesting features that I am very excited about it is the enterprise web UI. It is an enterprise features that we introduced in 2.1. So basically, we have created a web interface that allow to reconfigure ProxySQL and visualize all the configuration of ProxySQL and how it's behaving, what are the statistics, extract more statistics about the monitoring module, and so on. All this in a very easy to use web interface. So it will be extremely easy to configure and to have a feeling of what is happening inside ProxySQL. So I would say those are the three main features that I am excited about.
Well, this is, I tell you, this is going to be a delightful release. I tell you why. The observability of Proxy SQL infrastructure till in the recent past was always a challenge, because how do I proactively troubleshoot Proxy SQL, right? With integration with Grafana, with your own, more visibility towards Proxy SQL operations metrics, I can be more efficient in troubleshooting the Proxy SQL infrastructure. Thanks, Rene, about it.
Okay.
Rene, how do you measure maybe a customer story who adopted Proxy SQL maybe earlier, maybe later, but then they used Proxy SQL to the best of their capabilities, and how they benefited it? Do you want to discuss about that?
Yes, one of the most interesting stories that comes to mind and is the deployment of ProxySQL for its multiplexing ability. So that is the ability of using the same backend connection for multiple client connection. So this is a feature that is quite different from other proxy like HA proxy, because this is a pure TCP proxy. So instead of having a one-to-one mapping connection, like one client connection maps to one backend connection, ProxySQL you can have multiple client connections that are mapped to one single backend connection. And the reason why this is quite an exciting feature for many of the users is that when they deploy ProxySQL, they see the database connection dropping from 20,000 to 80. Those are actually real number. And their first suspicion is something is not working, because it's quite difficult to understand that before you had 20,000 connections to the database server, and now those connections are down to 80, and you have no performance penalty, but actually MySQL is processing those queries even faster. So huge number of connection dropped, and performance are getting way better. That's one of the feature. Another example I can think of is ProxySQL being used for routing, for very complex routing. So basically, for sharding, basically a combination of sharding and routing. ProxySQL is able to perform sharding based on the username and the schema name. And we have quite large customers that has configured ProxySQL with more than 100,000 database schema, sorry. And ProxySQL, based on the database schema, knows on which server it has to send the traffic. So it has a very fast table to perform the lookup. So based on the schema, it knows to which server it has to send traffic. So yes, quite impressive setup.
Wow. All right. Thanks a lot, Rene, for sharing about the best methods, practices to use Proxy SQL, how to adopt, about new release features. We are excited. Thanks for being very active in making this community always growth oriented, like focused on on sharing the knowledge what you gained over the period of time. That actually fuels the entire open source community. Thanks for all your commitments and all your support towards the ecosystem. Personally, want to thank you for coming for MinervaDB Athena 2020 once again. Wishing you in advance Merry Christmas, a great 2021, which let you travel more freely. All of us travel a lot, meet each other, and wishing you a safe year ahead, man.
Thank you, thank you. It's my pleasure to be part of this community, and I mean, it's a community that I really loves. And likewise, I wish you a great Christmas and a happy New Year for 2021. Hopefully, it will be a great year.
Thank you so much.
Thank you very much.